In this video, we're going to do questions 8 and 9 from the two-step problems that have us connect our two main formulas together, the mass and the particle formula. So we'll start with question 8. How many grams are in a sample of H2S that contains 7.02 times 10 to the power of 24 atoms total? So we're looking for the mass here. So let's just make that clear. So we want to get the mass. So we're looking for mass, and we know to get mass, let's just write this down. We need the number of moles times the molar mass. And so luckily we have our molar mass of H2S already. We've already calculated a number of times. We're just going to get it from previous questions, but if you didn't have it, you go in your periodic table to calculate it, and that's 34.09 grams per mole. Okay, so we know that. Let's just make a little plan here of what we're doing. We need to go from the number of atoms in H2S total all the way to mass. So we need to find the number of moles. We need to find the number of moles, but we don't have enough yet. Remember, to find the number of moles, we need the formula N is equal to big N over NA. Okay, this is my planning here. I'm just showing you my thought process. So I have NA, I have Avogadro's number, which, as we mentioned in the previous videos up here, 6.02 times 10 to the power 23 particles of H2S per mole in this case. So I still need N, though. Now, look carefully. We have the total number of atoms here. To find N in H2S, I need to do a conversion. So here's what I know. I know that in one H2S, there are 3 atoms total. Okay, so I'm going to make this my step 2, finding what I need, which is the N, the big N value. And so what I'm going to do is I'm going to take the number of atoms given to me and multiply that by the conversion factor to get rid of atoms. So basically do times 1 H2S per 3 atoms. I'm just dividing by 3. Right, I gave you the total number of atoms, just 3 atoms total. Divide by 3, and I get the number of molecules that I had. So this crosses atoms out and atoms out. And so we put that in our calculator. We get 7.02 times 10 to the power of 24 divided by 3. And we get 2.34 times 10 to the power of 24 H2S molecules. So we have that now. And now that we have the number of molecules, we can go and find the number of moles. Now, just to be clear, I want to show why I did this. Okay, so suppose I said you had H2S. And I said that in that sample of H2S, there are a total of 6 atoms. How many H2S are there? Well, in one H2S, there's 3. So in two H2S, there's 6. So there'd be 2 H2S. What you would do to figure that out is you would just do divided by 3 atoms per H2S. And then you'd get 2. So I kind of did that process there, just with a different number. Anyways, now that we have our number of particles, we can go ahead and find the number of moles. So now we can do the number of particles is, so N is equal to 2.34 times 10 to the power of 24 H2S molecules. Divide that by Avogadro's number, 6.02 times 10 to the power of 23 H2S molecules per mole. That crosses H2S molecules out, and we're left with moles, which goes at the top here. And so we would get, so put that in there, then divide by 6.02 times 10 to the power of 23. And we get 3.887. And you can keep going. So I would keep going there. 0.43189 moles. We're almost done. Now we just need to go and plug that into our mass equation. So now the mass is going to be equal to the number of moles we found there, and you'd keep all your digits in your calculator. I'm not going to write all of them down again. Times the molar mass, which was 34.09 grams per mole. Cross moles out, left with grams. And we get 132.5093023 grams. Therefore, the mass is approximately, we need 3 sig figs, 132. Let's round it 33 because there is a 5 there, but there's a lot of stuff after the 5. And so we'll round it to 133 grams. So we round it up to 133 grams, and that is our final answer. So we essentially, we're going to use a mass formula, but we didn't have the moles. We had the number of atoms, so we had to use the number of atoms to find the number of moles. Then we use the number of moles to find the, we've used the number of atoms to find the number of particles. Then we used the number of particles to find the number of moles. Then once we had the number of moles, we could use our mass formula. And I just want to clarify, I rounded up to 133 grams there because after the 5, there were numbers that followed. I think in the previous video, I made a mistake with that, and I rounded down when I should have rounded up. Just go back and double check just in case you see that I did that. How many atoms of hydrogen are contained in 250 grams of water? So I'm going to try to do this only with conversion factors. You'll get the same answer if you do it with the other method, but I'm just going to show you with conversion factors how that would work out. So we have 200. We want to go from mass to moles to number of particles to number of H atoms. That's our plan. So we're going to do 250 grams times our conversion factor of molar mass, which is grams per mole. So we're going to have grams at the bottom, 1 mole on top. And the molar mass of water is 1.01 times 2 plus 16, 18.02. That crosses grams out, we're with moles. So now we're going to try to get to number of particles by doing 1 mole and then 6.02 times 10 to the power of 23 H2O molecules. And so mole and mole cancel out. And then finally, we're going to do times 2 H atoms per 1 H2O molecule. And so that'll cancel out the H2O molecules. And at the end, we're left with H atoms, which is the unit we want. So we do 250 times 1 divided by 18.02 times 6.02 times 10 to the power of 23 divided by 1 times 2, and we get 1.67036626 times 10 to the power of 25 H atoms. Therefore, number of H atoms is approximately, we need two sig figs, 1.7 times 10 to the power of 25 H atoms. So that is just using conversion factors. You could have used your formulas as well. So there's not a lot of room, but I'm going to do it very quickly here. You'll be more organized when you're doing it, but let's just say we want to use the formulas. What I would do first is I would write down that I'm looking for the number of H atoms. So to find H atoms, I know that I'm going to do my number of particles times 2 H atoms per H2O molecule. Okay, per H2O molecule. And so to do that, I need my N value. So to find my N, I need to do N is equal to number of moles. Let's make that neater. N is equal to number of moles times Avogadro's number. We already have Avogadro's number. I just need to find N. To find N, I'm going to do my number of moles is equal to my mass over my molar mass, which is equal to 250 grams divided by my 18.02 grams per mole. Cross grams out, moles at the bottom twice, so it comes to the top. And so we would do 250 divided by 18.02. We would get 13.87, so on and so forth, moles. Then I would do my step 3, which is to find my number of particles. I would go back to my formula there. Number of moles, 13.87. I kept all of them in my calculator, though. Times Avogadro's number, which is 6.02, times 10 to the power 23 H2O molecules per mole. Cross out mole, cross out mole. And we would get 8.35 and more, but we would get 8.35 times 10 to the power of 24 H2O molecules. And then finally for my step 4, I'll start it over here. I would do that number of particles there, 8.35 times 10 to the power 24 H2O, 24 there, H2O, multiplied by 2H per H2O. Cross out H2O, and we're left with H's. And that would be equal to our same number there, 1.67, so on and so forth, times 10 to the power of 25 H atoms. And then you would have your therefore statement, and then you'd round to your number of significant figures that's correct. So therefore, approximately 1.7 times 10 to the power of 25 H atoms. And so that's using the formulas. You get the same answer using the conversion factors, whatever you feel most comfortable with. So in this video, we saw questions 8, 10, 9. Again, I just want to remind you that I believe I made a mistake with rounding somewhere in one of the questions. If I do find it, I'll make a note about it. If you find it first, maybe you let me know, and I can go make a note about it to where I did the rounding by 5 incorrectly. So hopefully you spot it before I do. If you have any questions, please make sure you ask, and please make sure that before you go on to any of the homework, you're able to do all of the problems in these notes. If you can do all these problems very, 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 very easily after going over the notes, then you know you're ready for the homework and you have a good, solid understanding of these concepts. So don't go attack the homework until you know and understand all the material and all the problems in these notes.